Okay, our lesson today, your learning target, you're going to be able to simplify fractions. The difference is you're going to do it with variables. So it's all part of simplifying normal fractions. You need to know some vocab word, though, that's aligned with when you have an algebraic fraction. You need to know what expand means. Expand means, I should say. And it means to write out fully. For example, if I have x cubed, to expand it, I would write x times x times x. Right? We're all on the same page there? And a reminder, exponent means repeated multiplication. It's not addition, it's not division, it's multiplication. So you're going to have to simplify normal fractions today and algebraic fractions. I am not going over normal fractions. Normal fractions, I think you know how to do. It's not worth the note space. We're going to just jump into something that may be new with the algebraic. And what you want to do for simplifying algebraic, expand the variable out. Expand the variable. And then what you want to do is cross out shared variables on the top and bottom, or common variables. I will write shared. Cross out shared variables on the top and bottom. And then lastly, you can just it back together and you write it with exponents. Okay? So, for example, a squared over a to the fifth. According to my steps, the first thing I should do is expand the variable. So I'm going to have a top and a bottom. Don't get rid of the fraction bar. The top has 2 a's, so I expand that out. The bottom has 5 a's. 1, 2, 3, 4, 5. Now I cross out what they have in common. Cross out. Cross out. Can I cross any more out?
No.
So what do I have left on top? Is it a 0 or a 1?
0.
It's a 1. It's a 1 because 0 over anything is going to be 0. So I know that this isn't 0. So I know that I have to say, okay, this isn't 0, so bring 1 out to play. So my final answer, write it with exponents, so it's 1 on the top, a to the, how many a's? A cubed, yeah? 1 over a cubed. Woofta, look at this next one. Let's go down one before I do this.
No, I like the next one.
Well, that's fine. We'll get there. I want to just slowly get there. I'm going to go in a counterclockwise direction. Okay, so how many x's do I have on the top? Write them. 1, 2, and 3. Remember, I don't even have to include the dot in there because anytime 2 variables are sticking together, it represents multiplication. So I don't have to write the dot. Y to the 4th, how many y's? Huh?
4.
1, 2, 3, and 4. Over x, y to the what? So 5 y's. 1, 2, 3, 4, and 5. And this is my, I don't know why, but I love this cross-out part. And I never get sick of it, and I'm very old, and I've been doing this a long time, but I still love it. Because I'm like, oh, hey, cancel out anything that they share. They share that x. What else do they share? No more x's, so now I got to go to the y's, right? So you might want to start at the end so you don't get confused and accidentally cross an x out. So I'll just start at the end. Share, 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 right? Now make your fraction bar because you have to have a top and a bottom. What do I have left on top? So x squared, right? And then what do I have left on the bottom?
Y.
X squared over y. X squared over y. So again, my process. Expand, cross, rewrite. Expand, cross out, rewrite. Okay, next one. Looks like I have 2 x's, 1 and 2, and 6 y's. 1, 2, 3, 4, 5, and 6. Over 3 y's, 1, 2, and 3, and 4 z's. 1, 2, 3, and 4. Cross out what I can. Can I cross any x's out?
No.
I can cross some y's out, so cross. See how it looks confusing? It looks like I crossed my x out already. Be careful for that. I didn't. Cross out. Cross out. And that's it, right? That's all I can cross out. So now I rewrite. Remember, you have a top and a bottom. What do I have left on top? X squared, and what else?
Y cubed.
Y, I have 1, 2, 3 left. Y cubed. Over z to the 4th. X squared, y cubed, over z to the 4th. Okay, this last example on this page, I'm going to need space because I see a lot. I see a 5 and a 7, and oh my gosh, I need a lot of space. So here I go. 2 A's, 1, 2. Oh, I usually always write my fraction bar first. 5 B's, 1, 2, 3, 4, 5. 3 C's, 1, 2, 3. 2 A's, 7 B's, 1, 2, 3, 4, 5, 6, 7, 2 C's. Cross out, cross, cross. Okay. Cross, 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 cross. Cross out my C's. What's left? I have a C on top and 2 B's on the bottom. C over B squared. Okay, the next concept aligned with simplifying algebraic fractions is if we have coefficients. The first thing I do, now there's multiple ways to do this, but the first thing I do is expand the exponent. That's the first thing I do. And then at the end, I simplify the coefficients. Now let me model through an example. I'm going to expand this top out, so it's 3, and how many x's? 4. 1, 2, 3, and 4. That looks like a y. And then on the bottom is a 9, 1x, and 2 y's. So I'm simplifying what I can, crossing out what I can. And then on the top I have 3x cubed over 9y squared. So I'm dealing with my variables first. And then I simplified this into 1/3. Do I have to write the one when I rewrite this?
No.
You don't have to. If 1 can hide, let it hide. Remember, it's the shyest number in the world. So I would just write x cubed over 3y squared. So to reiterate my process, I expanded, I rewrote, and simplified, and then rewrote again. So rewrote, simplified, rewrite again. All right, here we go, another one. First expand, 36, 2 A's, 4 B's. Over, now some of you might be seeing the pattern now too, and that's cool if you see it. It's there. And once you spot it, you'll be like, how did I not spot it before? Okay, it's one of those patterns that are right in front of your face, but it takes a minute to notice it. 3 A's on the bottom, 4 B's on the bottom. and a C on the bottom. That was my step 1. Now I'm going to go to step 2, which is rewrite. Cross, 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 cross. On the top I have 36, just 36, right? I cross everything else out. Over 12, I have an A there, and I have a C left. What do 36 and 12 have in common? 3, 12, 2. If we use 3, there's no problem using 3. We'll just have to simplify a couple times. So I'm going to write 12. And now totally rewrite. 3 over, let 1 hide, AC. How are you feeling with this? Feeling okay? Well, we are almost done. Just a few more examples. Okay, this one, expand, negative 15, 4 x's, a y, 5 z's, over 35, and 4 y's. 1, 2, 3, and 4. Okay. Not much I can cross out, so I pretty much just wasted my writing time. But that's okay. So now I have negative 15, x to the 4th, z to the 5th, over 35, y cubed. Now I'm going to simplify. They both have 5 in common. That would be 3. That would be 7. Rewrite pretty. And that would, I need space. That would be negative 3 x to the 4th, z to the 5th, over y cubed. Done. Where? Good job. Done. 7y cubed. Poor little 7, I forgot about it. Now this is where my 8th graders get stuck. They forget that they can apply the variable rules to numbers. And what kids usually do here is they figure out what 3 to the 4th is, figure out what 3 to the 2nd is, and then divide them. I wouldn't do that. There is a much easier way. Expand them out. I have 4 3's. I have 2 3's. Cross, cross. I'm left with 3 squared. What's 3 squared? 3 times 3 is 9. So I would utilize that strategy. And so many of my kids, now look at this one, 5 to the 6th. That's a huge number. That's a really big number. And 5 cubed is 125, another big number, but definitely easier to handle. It is so much easier, though, to expand. But a lot of kids think expanding is only variables, and it's not. You can do it with numbers. So this is equal to 6 5's, 1, 2, 3, 4, 5, and 6, over 3 5's, 1, 2, 3, cross out. I'm left with 3 5's, which is 125.